Hi class, let's take a look at example 2. Now, example 2, it's a little bit iffy because of the notation and also because of the distribution. Now, the mathematical notation for 0 to 1 basically means that it doesn't include these two, but because of the definition of being part of the uniform distribution, it has to include them. Otherwise, we don't have an area. So when we talk about the actual sketch, you're looking at the following sketch for this distribution. So technically, it cannot go beyond 1. And then the value of p of x, the maximum that's going to be is 1, since the total area under the curve happens to be 1. So this specific computer program, in this case, this is equal to numbers. The title, I'll just write it as computer program. It's actually gonna provide us with any, let me rewrite that, any number that's between technically the values of 0 to 1. It cannot give you anything on the outside, and more importantly, you have to include the edges, otherwise you don't have a squared, since technically the distribution has to be some sort of a square or rectangle. Okay, so that's pretty much it for the distribution. Let's take a look at problem B, and then in all of these, they're going to want us to do sketches. So let me declare the variable so we don't have to actually worry about that. So in this case, let x equal to a number. Okay, so for this distribution, let me just say that the values of p of x and x is less than or equal to 0.7 and greater than or equal to 0.3. So the sketch of this one is actually going to be as follows. The maximum is 1. These are numbers. This is 1. That's our p of x. But this particular one, only it's going to go from 0.3 to 0.7. So in this case, we're looking at this actual chunk, which means that this is actually 0.4. So the length times width on this one, it's going to be 1 times 0.4. This is equal to 0.4. That would be our answer for this particular one. Since the random variable in this case is a number that is given by this computer program, it's going to be between 0.3 to 0.7. Let's take a look at C. In C, they also want to sketch. Let me just write it underneath. And this is one also, we're talking about numbers. That's one, that's p of x. And then this is 0.5. So our probability, in this case, well, half of it, it's going to be 0.5 with the height of 1. So this is going to be 0.5 times 1. This is equal to 0.5. That's going to be the probability that the number happens to be less than or equal to 0.5. Let's take a look at part D. In part D, they're saying that this particular one happens to be greater than 0.2. So let me just draw the sketch here. And this is technically 1. You're still talking about numbers. This is 1. This is our p of x. And then we're looking at this is 0.2. So the area in region happens to be above technically the 0.2, which happens to be 0.8. So the probability of this one, it's going to be 0.8 times 1. This is equal to 0.8. Let me jump to E. And E could be messy, but in this case, this is still 1. You're still talking about numbers. This is 1. This is your P of X. Now, let me actually rewrite the formula. So remember that this is actually an OR statement. So if you were to evaluate the OR statement, this one would be the probability that X is less than or equal to 0.5 plus the probability that X is greater than or equal to 0.8 minus the probability that X is less than or equal to 0.5 intersection X greater than or equal to 0.8. Oh, shoot, it doesn't fit. Let me rewrite the formula again. Okay, so formula-wise, this is the probability that X is less than or equal to 0.5 plus the probability of X is greater than 0.8 plus the probability that X is less than or equal to 0.5 intersect X is greater than or equal to 0.8. This is the intersection, and I'm just using the formula from section 5.2. Now, less than or equal to 0.5, so that is 0.5, and less than or equal represents every value to the left. So this is going to be 0.5. So the first portion is just going to be a 0.5 plus greater than or equal to 0.8, and let me do 0.8 in blue. So 0.8 happens to be from here up, that would be 0.2. So that area, in this case, this chunk is going to be simply 0.2. Since you're going to have 0.8 to 1 is 0.2, and then minus, there's no intersection on this one, so our final answer is just going to be a 0.7. Since technically you're going to get from 0 to 0.5 a total of 0.50%, from 0.8 to 1, that's 20%. So combining those two, it's going to give us 0.7, or you can rewrite it as 0.70. Either one of those is fine. The last one, they're asking for greater than 1.5. I could just rewrite it as the probability of X is greater than or equal to 1.5. And there's a minor problem. Let me draw it here. The problem here is that, well, your distribution only goes to 1. So technically, any value that you're obtaining, it's only going to be between 0 to 1. 1.5 is about here. So this is 1.5. So because it's outside of the event, that is automatically 0. So you cannot have any value that is actually exceeding the original problem. In the original problem for the distribution, we were given that it technically goes only between 0 to 1. So therefore, the last one, it's not going to be any numerical value other than 0, since it's outside of the event.